Hello everyone, welcome back. This is Mr. Hussein Mosapi. So in this video we'll be looking at a revision involving deformation of solids. It highlights a lot about Hooke's law and other necessary subtopics. Alright, so before we begin, don't forget to like and subscribe. Alright, so question 1 says, what is the formula relating the force of a spring and its distortion? Alright, so this one is quite simple. The formula relating the force of a spring and its distortion is simply F being equal to negative Kx. As simple as that. Now B is asking us to explain why it's negative. As you pull a material to a certain length and decide to let go from one end, the material will tend to go back to its original length. The force at which it goes back to its original length is the restoring force. So the reason why it's negative is because it's the restoring force. Simple as that. Let's move on to a different question. Question 2 states that a force of 16 newtons, so we can do some data here. A force of 16 newtons is required to stretch a spring a distance of 40 centimeters. So the distance is 40 centimeters, of which we know if we have centimeters, this should be in meters, so divided by 100. So we're basically just having 0.4 meters. That is the distance from its rest position. Now what force in newtons is required to stretch the same spring twice the distance? Alright, so for A, we'll say let's use a direct proportional thing. Let's use ratios or variations to say. So we know that 16 newtons produce what? 0.4. Now, what force will give me a distance that will be 2 times the initial? So we say 2 times what? 0.4. If you do the math, you'd find that you have cross multiplied of 0.4 times F being equal to 16 times 2 times what? 0.4. So if you divide both sides by 0.4, even the other side 0.4, you find that the force that you want here is equal to what? 32 newtons. You do the same with B. You know that 16 is giving you what? 0.4. Now what force will give you 3 times of 0.4? You cross multiply, you have 0.4 times F being equal to 16 times 3 times 0.4 divided by 0.4 divided by 0.4. F is going to be equivalent to 48 newtons. C says 1/2 the distance. So 16 can produce 0.4. What if the distance is half? So 0.5 times 0.4, because 1/2 is half and half is 0.5. So 0.4 times F being equal to 16 times 0.5 times 0.4 divided by 0.4 divided by 0.4. So the force is equal to 8 newtons. Let's move on to the next question. Now, you can pause and attempt to do this question, then compare with what I would do. For question 3, it says a mass of 5 kg will stretch a vertical spring. So okay, let's just do some data. So I've been given a mass of 5 kg that will stretch a vertical spring to that length. So I have an extension being equal to 3.25 centimeters. So since it's in centimeters, we convert to what? Meters. Therefore, extension is going to be now what? 0.0325 meters. Once we do this, all we have to do first is to draw a free body diagram showing all the relevant forces and values. Alright, so be mindful of this. A free body diagram is a representation of something complicated in a not so complicated way, showing all the relevant forces and values. So the free body diagram will have a fixed support there. Then we'll have our spring and the mass. So the mass, which is 5 kg, the force is the weight force mg, 5 times 9.81. So this will give us 49.05 newtons. So we know that this is to a length of 0.0325 meters. Then we've been asked to calculate the spring constant. So we know that force is equal to K what? X. Our interest is K. So we divide by what? X. Therefore, the spring constant is force over what? Extension. So K is equal to the force, which is the weight here. So it's going to be 49.05 divided by the extension, this guy here, and you have 0.0325. So K will now be equivalent to 09.2 newtons per watt meters. If we round this off, the spring constant is 1509.2 newtons per watt meters. As simple as that. Let's move on to question 4. A horizontal steel spring has a spring constant of 40 newton per meter. So here, if we collect our data, we know that spring constant here, K value is 40 newtons per watt meter. So what force? So we want the force. This spring is needed to be applied to spring in order to compress it by that. So compression here is 10 centimeters divided by 100. This gives us what? 0.1 meters. So we say force is equal to what? Negative K watt X, isn't it? So we're going to say force is equal to negative, since it's a compression, so we're going to be having a restoring force. So the constant is 40 times extension 0.1. So force is equivalent to -4 newtons. As simple as that. So don't forget to be trying out the questions as we are revising together. You can always pause the video and attempt to do the questions that I'm doing so that you get familiar with your abilities. Let's move on to question number 5 now. Now it says when 14 kg, so let's pick our data. So when 14 kg, so when the mass is now what? 14 kg. Hung from the spring with the spring constant, so the spring constant is given to be 550 newtons per meter. The spring has a length of that, so this is length final because it's when the mass has been hung on it. So it's in centimeters divided by 100. Basically, we end up having 0.8 what? 2 meters. Okay, let me just write this properly. 82 meters. Alright, so now determine the length of the spring before any force is applied. Okay, so we're going to say, okay, this is going to be in this manner. We'll say force is equal to what? Kx. This means that the force is equal to K, changing what? Sorry, not changing lengths. Length final minus length what? Initial. If we substitute, we're having the force, which is what? So the force here will be the weight. So weight is equal to what? Mg, and the mass is 14 times 9.8 what? 1. So the weight will be equivalent to 137.34 newtons. With this, we can now plug. So we'll put 137.34 being equal to the constant 550 times length final 0.82 minus length initial, which we're interested in. If we simplify furthermore, 550 times 0.82 will give us 451. Then that times that will give us 450 initial. So if we could take this side to be better, so we have positive 550 L naught being equal to 451. This comes this side, so it's going to be negative 137.34. I can also say divided by 550 divided by 550. L naught is equal to, if you compute this, you have 0.5700291 meters. Round it off, the initial length is 0.57 meters. Alright, let's push to question 6 now. Okay, let the spring constant of your lab bench, if it is known to bend down to 0.10 millimeters when a 57 kg student stands on it. Alright, so according to our data, we have the extension being equal to 0.10 millimeters. I have to convert this to meters. So x is equal to 0.10. Since it's millimeters, we divide by 1000. This gives us 1 times 10 to the minus 4 meters. From there, we also need to know the force. So to find the force, we know the mass. We can say weight is equal to mg. So 75 times 9.81. So the weight is equal to 75 times 9.81 will give you 35.75 newtons. Then you can say force is equal to kx. We want the constant, so divide by x, k is equal to f over x. The force is 735.75 over the extension, which is 1 times 10 to the minus 4. Now, if you simplify this, you end up having 7357500 newtons per watt meters. Just like that. Alright, let's look at question 7, which is basically the last question. So it says spring A will stretch vertically by 20 centimeters when it has a mass of 1 hanging from it. Spring B will stretch vertically 50 centimeters when it has a mass of 1 hanging from it. Now I've been told to draw a free body diagram of spring A, including all the relevant forces and values. Draw the same for B, doing the same. So here we have the fixed supports. Just draw it roughly, because we already have ideas of what we want. So it's going to be 20 centimeters. Put the mass, which is 1 kg, the weight force mg, which is 1 times 9.81, which is just 9.81 newtons. So this is for spring A. Then for spring B, it's the same thing. Just have to change the extension. So you're having that, the mass of 1 kg, so which means that the weight is mg. So 1 times 9.81, which will give us the weight of 9.81 newtons. Then here we know it's going to be what? 50 centimeters. Then that's your free body diagram. This is for spring what? B. And so you can get the spring constant for A. So remember, F is equal to K, x divided by x divided by x. K is equal to F over what? X. The force is what? 9.81. Then the extension is 20. So I can say 20 times 10 to the minus 2. Because 20 times 10 to the minus 2 is the same as 1 saying 20 divided by 100. So the constant here will be 49.05 newtons per watt meters. We do the same for B. So when K is equal to F over X. So the force is what? The force is 9.81 divided by the extension, which will be 50 times 10 to the minus 2. And this will basically give you 19.62 newtons per watt meters. So now all we have to do now is to move on to the next part of the question, which is D. D basically looks very interesting. It's very interesting, but It's again very simple. It's actually very simple to solve this one. So what I'll do now is this. Let's try and solve it from this point of view. So now it says that suppose that that's the 1 kg mass hanging from the end of A, which is hanging from B, assuming that the mass of the spring is negligible, forget the total amount of stretching. So what's going on is this. You're having this. So you're having one spring. So let's call this spring B. Spring B. Then at one point, spring A is also attached. Spring A is attached. Then you're having your mass, which is what? 1 kg. Which creates the weight equal to mg equal to 9.81 times 1, which is 9.81 newtons. So we know that from here to there it's what? 50 centimeters. From here to there it's what? 20 centimeters. So if we get the total extension, we know the total extension will be extension 1 plus extension 2. So the total extension will be 50 plus 20, giving you what? 70 centimeters. You need it in meters, so just say 70 divided by 100, which will give you 0.7 meters. Now with this, you can now solve E. E says calculate the spring constant. So you know F is equal to what? Kx. So divide by x, divide by x. K is equal to F over what? X. The force is the weight, so 9.81 divided by 0.7. So the K will be 14.0 newtons per watt meters. Alright, thanks for revising with me. My name is Mr. Hussein Masapi. Go through this revision a couple of times to get a hang of these topics. Yeah. Remember to like and subscribe. If you have questions, you can reach me on WhatsApp on this number here or the one in my description. Don't forget to strategize before you become a statistic. Let's push for a plus.